This is an important question on ABC factoring. A lot of people don't realize that this type of factoring is important for the digital SAT. So first off, let's just review that a quadratic is in the format of ax squared plus bx plus c. That's important to know because for BC factoring, that's a situation where you have a number in the B spot and in the C spot. For instance, if we had x squared plus 7x plus 12, in that situation, we'd be looking for two numbers. Let's just fix this up. We'd be looking for two numbers that add to 7 and multiply to 12. And those numbers would be 3 and 4, so it would factor to x plus 3 and x plus 4. However, if we had another quadratic that was in an ABC form, in other words, if we have numbers in all three of these spots, we have to change our saying a little bit, and now we need two numbers that add to B and multiply to AC. So that's what this is. Here we have 3x squared plus 20x minus 63, and we need two numbers that add to 20 and multiply to negative 63 times 3, which is negative 189. So that's kind of a complicated set of numbers there. But when you have these, you can just divide straight down, and it always goes surprisingly quickly. So if we divide 189 divided by 1, it's obviously that. It doesn't divide by 2 because it's odd. Dividing it by 3, it's 63 times 3. Once again, it won't divide by 4 because it's odd. It won't divide by 5. Will it divide by 6? Let's see. 189 divided by 6, 31.5. 189 divided by 7 is 27. So 27 times 7, and that's it. We've reached our number. First of all, in terms of the signs, we knew that this multiplied to a negative because we see it's multiplying to negative 189. That means that we have opposite signs, one positive, one negative. And of those opposite signs, we knew that it added to a positive, and therefore of those opposite signs, the bigger looking number is the positive 1. So out of our 27 and 7, we need positive 27 and negative 7. So the next thing you do in the ABC factoring method is you take that middle term, which for us is 20x, and you split it into 27 and negative 7. So plus 27x minus 7x. So 3x squared plus 27x minus 7x minus 63. The next thing you do in this process is the factor by grouping method, which is the idea that you take the first two and you take a GCF there, and you take the second two and you take a GCF there. So the greatest common factor, the GCF, of 3x squared and 27x is 3 times x. So if you divide them both by 3x, you're going to get x plus 9. Now the greatest common factor, GCF, of the next two is minus 7. And if you factor that out, you'll get x plus 9. Now, a quick word about the signs. If I distribute here, I'd get negative 7x minus 63, which is great. But if I were unsure and I factored out positive 7, when I distribute back, I would see that it doesn't work. And so really, with some of these sign issues, we're not always 100% sure of how it works, but anything we do, we can multiply it right back out to find out if we did it well. Now we have two terms. We have this term and this term, and they both have a common factor of x plus 9. So if you factor that out, we're left with 3x minus 7. So our factors are x plus 9, not x minus 9, and 3x minus 7, which matches. So the answer here is B.